Hello everybody, welcome to the next episode of Geometry. We are looking at area. We've been looking at different shapes, two-dimensional shapes, and finding the amount of two-dimensional space on the inside of that. So we're going to continue on with that today. Objective is going to be able to find area, again, of composite figures. And I'll explain what that means. But so far, these are the different shapes we've been looking at. The first one we started off with was a parallelogram. Remember, that was base times height, where base and height had to be perpendicular. I see perpendicular right here. That means this is the height and this is the base. So this one would be 15 times 5, which is equal to 75. Down here, a triangle. Remember, triangle is just a half of a parallelogram, so it's 1/2 the base times the height, where base and height have to be perpendicular again. I see perpendicular right there happening, which means 12 and 6 must be the base and the height. So this would be 1/2. 12 times 6. That's equal to 36. Then on the trapezoid, that was a complicated formula. That was what? 1/2 the height times base 1 plus base 2. Base and height still need to be perpendicular, which means that 4 is going to be the height, and 10 and 3 are going to be the two bases. So this would be 1/2, 4 times 10 plus 3. So that's equal to 26. Kites and rhombi, they had the same formula. That was 1/2 diagonal 1 times diagonal 2. So remember that the long diagonal bisects the short one in a kite, which means this other half must be 3 over here, which means the total distance on this diagonal would be 3 plus 3 or 6. This other diagonal is 11, so this would be 1/2 of 6 times 11, which is equal to 33. Areas of circles and sectors. Circles are what? Pi r squared. A sector is the central angle over 360 times pi r squared. Here they want me to find the area of this sector. Notice the shaded portion is the large portion. The unshaded part, which I don't want to find the area of, is 50 degrees. So remember, this is 360 degrees the whole way around. So to figure out how big that is, I would do 360 minus the 50, and that's equal to 310. So that's a 310 degree central angle. So remember, to put that over 360, and then you multiply that times pi r squared. R in this case is that 8, so it'd be pi 8 squared. So again, the way I would plug that into my calculator is I would do the 310 over 360, figure out what that is, and then multiply that times pi 6 or 8 squared. Just like that. So I end up with 173.1. So that's sectors. Then the last thing we looked at were regular polygons. Remember, regular polygons, the formula is 1/2 AP. I'm always going to give you that apothem. I forgot to give it to you in this example, but let's make the apothem equal to 3. So now I have 1/2 AP. So that would be 1/2. The apothem, which I just gave you, is 3. That'll always be given to you. Perimeter, I got to do a little work to get. This has got 1, 2, 3, 4, 5, 6 sides that are all 4. So this would be 4 times 6. And so that ends up being half of 24 is 12, so it's 36. So that's the area of regular polygon. That's where we left off. All right, so today we're going to add to our repertoire of finding area, and we're going to look at composite figures. Composite figures is basically a couple shapes put into one. So the way you're going to do this is you're going to break into familiar pieces. Break shape into familiar pieces. Again, these familiar pieces will be like parallelogram. They'll be like a triangle. It'll be like a circle, etc. So the familiar pieces will be those, and you'll be either adding or subtracting those areas. I'll show you what I mean in these examples down here. So this is an example of a composite figure. So if you ever hear that word, it's going to be something like this. So in this one, this is pretty simple. I see basically two rectangles. I see this little rectangle on top of this bigger rectangle down here. So what I can do is I can simply find the area of the two rectangles, add them together, and that'll be all the shaded area. So let's see, the top rectangle here, area is going to equal base times height again. I got to do a little work to get the base and height. Well, the base is going to be this down here, which is 4. The height I can get by using this 6 and this 10. So again, if this is 10 all the way from here up to here, and it's 6 from here to here, that means I need to go an additional 4. So that would be my height on that one. So the base is 4, and so is the height. So that's equal to 16. And then the bottom rectangle, also use base times height. Base and height, again, this would be the base down here. The height would be that 6 now. So this would be 12 times 6. And that's equal to 72. So then the total area, and I'll write total here to let you know that I'm talking about the whole shape, is going to equal 16, which was the green one, plus 72, the blue one. And that's a grand total of what? 88 inches squared. So that's one where I added the areas. An example of a subtracting the area problem is one like this. So this one, again, I noticed this overall green rectangle, but notice not all the area in there is shaded. The area that's not shaded in that green rectangle is this blue rectangle. So now what I need to do is I need to find the area of the green one and then remove the blue one. So let's start with the area of the green one. Area is a rectangle is base times height still. So let's see, the base I'm going to be able to get by using this 20. And then each of these distances between here is 5. So this is 5, this is 5. So if it's 5 from here to here, 20 from here to here, that's a total of 25, and then another 5 would be 30. So the base is going to be 30, and the height, let's see, I can count up the 5s here. So this is 5 from here to here, 5 from here to here, 5 from here to here. That means my height is 15. 5 plus 5 plus 5. So I do 30 times 15, I think that's 450. Yep, so that's 450. So that's the area, the overall green one, but again, I don't want all that area. I don't want this part of it in here. That area is going to be base times height again. Base is now 20. Height on it is 5. So that area is 100. So now when I go to find the area total, it's going to equal the big green minus that 100. I don't want to, it's not shaded, so I'm going to remove it. So it's 350 inches squared on that one. Number 3 is pretty hard. 3 is like the hardest one here. I see 3 shapes on number 3. I see a rectangle right here. I see a half a circle right here. Then I see a triangle right here. I'll start with the triangle first because it looks like to be the hardest. But if I find all that shaded area and add them all up, that'll be my total area. So in this one, I notice that I'm going to use area is equal to 1/2 the base times the height, because that's the formula for the area of a triangle. And the base and height have to be perpendicular. So I see a perpendicular there. The only problem is I'm missing this dimension right here. I can't really use the 7 or anything else to get it, but I do have 2 sides of a right triangle. Since I have 2 sides of a right triangle, I can always use Pythagorean theorem. So if I'm looking for that, I'm going to use Pythagorean theorem. So remember, it's leg squared plus leg squared equals hypotenuse squared. So this would be x squared plus 4 squared equals 5 squared. So this would be x squared plus 16 is equal to 25. That means x squared is equal to 9. That means x is equal to 3. So that's going to be basically the height of the triangle right there. So if I use the formula 1/2 the base times the height, I'm going to use 4 times 3 as the base and the height. So that's equal to 6. So that's for the triangle. Let's do the half a circle next. So the area of a full circle is pi r squared, but I only want half of it, so I'm going to divide it by 2. Again, it's not a full circle, it's a half of a circle. So again, get the radius. The radius is given to me right there at 4. So this is going to be pi, pi 4 squared divided by 2. So 4 squared is 16, half of that is 8. So this turns into 8 pi. I'll take care of that pi at the end of the problem using the calculator. Last shape that I see here is this rectangle that's 4 by 7. So area is equal to base times height. So base and height again are going to be 7 and 4. So that's 28. So now to find the area total on this. I'm going to add all these up. So I'm going to do the 6 plus the 8 pi plus the 28. And then I have to just use my calculator at that point. 6 plus 8 pi plus 28. And you see 59.1. So it's 59.1 inches squared. So that was 3 different shapes I had to add up on that one. Here again on number 4, another example of where you have to add some shapes together. So again, I see 2 shapes in particular. I have a trapezoid right here on top of a rectangle right here. Let's get the rectangle out of the way. Again, the shaded areas would be these 2 areas combined. So the area on this is base times height. Base and height are going to be 18 and 5. 18 times 5, that is 90. And then the area of the trapezoid up here, that's a little bit more complicated of a formula. That's area is equal to 1/2 the height times base 1 plus base 2. So in this one, the height, I can see the perpendicular right there. If this is 5, this whole distance is 12, and it's 5 from here to here. That means this distance would be 12 minus the 5, or 7. So then when you add 7 plus 5, you get 12. So that would be my height. Then the 2 bases are going to be this and this. Well, 8 is that base. This base will be the same as that, so this is 18. So then I'm figuring all that out. 8 plus 18, 26. Half of that is 13 times 7, so that's 91. So again, my area total is equal to 91 plus 90. That is 181. And that's inches squared. So that's how you do that one. Then down here, geez, I see a triangle over here. Let's see if I can do this one real quick before I run out of time. I see a rectangle here. And I see a half a circle right here. I'll start with the half a circle. Remember, pi r squared is a whole circle, but I only want half of this one. So then pi, my radius, I'm going to have to use Pythagorean theorem to get, This one's going to take me a little bit. All right, so again, the finished answer is going to be in the notes. So again, I have these all completed in the notes. I'm kind of running out of time right now. But again, composite figure, what that means is you're just going to break it into familiar pieces, and then you're either adding or subtracting them depending on what the shaded area is. So you have a few problems like this for homework. I posted the homework along with the answers, and then you can submit that. Then as usual, if you have any questions, you can give me a call or email me, or come to my office hours and I can answer those for you. Look forward to hearing from you. Good luck.